day 3, EOC. And again, you should be focusing on trying to get at least an 80% on each one of these. And I know some of them are harder than others, but that's just your goal. I want you to be able to see all of these. So I want you to continue, and then maybe you can go back later. Okay, so these are functions. It says these are functions, so there's no repeating x values, as you can see. And so we need to know if it's linear. So to be linear, and I feel like we're talking about this a lot. Oopsie daisy. So as far as figuring out if it's linear, you're looking at these patterns. So -2 to 2, you're increased by 4, increased by 4, increased by 4. Now let's look at our y values, because they also have to be consistent. So that was decreasing by 2, decreasing by 2, decreasing by 2. Since it's a constant addition or subtraction, it is called linear. Even if you're increasing or decreasing by 0, that's still considered linear. It's a constant repeat of. This one here, let's try it. Our x's, we're increasing by 1, increasing by 1, increasing by 1. Our y's, we're decreasing by 1, decreasing by 1. Oh, and then we added 1. So this is not linear. So you have to do it for each of them. This particular one, oh, this is exactly what I was saying. So you're not increasing or decreasing by anything, but it's a constant. And then here you repeated adding 1. So this would be considered linear. This one, as I go downwards, from here increased by 2 to here increased by 3. I'm sorry, from 1 to 5 would be increased by 4. So that would also not be linear. Looking at those patterns. This next question that you're going to encounter, that sunshine is always there every morning, and I don't want to say anything bad about the sunshine because I love sunshine. It's my favorite. So Keith is putting money into a checking account. So Y is representing the total amount of money that's in his account. X is the number of weeks. So Y is his total. X is the weeks. Okay. They are related. Here is the question. Okay, so note that a change can be increased or decreased. So all they're saying here, if it's an increase, you'll put a positive 20. If it's a decrease, a negative. So what is the change per week in the amount of money in the account? So this has to do with week. And this is our change. This is what's changing every time. Our slope is what's changing. So that's changing by $20. And our starting amount is the 450. That's like our initial amount. This is like our y-intercept here. Make sure you understand that. Our next one is a little funkier, and you definitely need a calculator. So here's our two functions, and we're going to fill out this table. So what you're going to do is you're going to take this 5 and you're going to substitute it here and here. So for the first one, they said 2 times 5 to the 3rd power, and that's how they got the 250. On this other function, the function of g, they said 2 to the 5th power, and they got 32. So I'm not going to do all of these, but I'm going to do the next one, just kind of write it out. Make sure when you're substituting in, you put it in parentheses so you get the right value. This one would be 2 to the 6th power. The last part of this question is confusing. So they're saying for anything that's greater than or equal to 12. So they're talking about everything here. Greater. 12 and 13 are greater than or equal to 12. So are my answers is f of x, so is this column here always, sometimes, or never less than this column? And then you just answer that. It's really not that complicated, but the way it's written is kind of confusing. So you know my x values are greater than or equal to 12. So they're only talking about this row and this row. According to this row, answer that question. Next. Done. Number 4, again, tables, tables, tables. You will see them. Let's see what the pattern is here. 59 to 38. I don't know. 59 minus 38 is subtracting 21. Obviously, from 38 to 22, 38 minus 22, you subtracted 16. 22 minus 11, you subtracted 11, and this you subtracted 6. Well, I'm not seeing a pattern there, but once I look here, it's going to be something. Okay, so this is nothing here, but when I look between, so this is a difference of 5. So I increased by 5 here, I increased by 5 here, and I increased by 5 here. So if you have this, and then something is constant, that's always quadratic. If on this one you can see I subtract 2 and then I add 2. So anytime you have this palindrome, so it's like race car, where it's starting to go this way and this way. So this, if I went to 1, I would probably have 11. If I went to 0, I would probably be at a 1. So it reads frontwards and backwards. That's always quadratic. And you know you can graph these ordered pairs on Desmos and kind of see what it looks like. The next one. So it looks like we're multiplying by 3. Yep, it's repeated multiplying by 3. Anytime you're repeated multiplying, it is exponential. So linear would be repeated adding or subtracting. And you really do need to check your x's, but all of these were pretty constant. The next question is a word problem, and I know how much you dislike them, but it's not that bad. So the sugar sweet company is going to transport its sugar to the market. This is the flat fee. That's that constant, your y-intercept. You're going to pay that no matter what to rent your trucks. And it's going to cost an additional $125 for each, that means multiply, tons of sugar. And that's going to equal how much it's going to cost. Now, if you want to use X and Y here and then change it to S and C, you can. Now it's saying, what happens if I have 17 tons of sugar? So where's the sugar? Right there. So then I would just substitute that in here. So 125, I don't need that dollar sign, but times 17, and that's going to give me this cost. Just substitute that value in. Graphing. We should be professional graphers. And I know you can't really see this because of the sunshine. That's really annoying me. Let's see if I change my lighting here. Let's go this way, and actually I'm going to turn my lights off in my classroom and see if that helps. Again, sunshine is my all-time favorite thing. Oh, well, that helps. All right. So all of us don't like it unless our equations look like this. Okay? We just struggle. But we can make our equations look like this. So all we need to do, the y can stay. We just need to send that 3x to the other side. And when I do so, I end up with, and I always put my slope first, and that's a -9. And now you guys should be professionals at this. This graph is extremely hard to see, but my y-intercept, see if I can see it. Okay, here's your x, and here's the y. And it is going up by 1, so I should be able to do that. So I'm going to start at a -9, which is way down here. Oops, it's right here. Here's my big dot. Can you see it? Okay. And then it says I'm going to go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. And then I'm going to use my straight edge, which you guys will have Alex, and I will connect those. Since this is equal, it is a solid line. No shading involved in this one. All right, so what's next? Anytime we have to graph a y equals or even an x equals, this is the y-intercept. So the y-intercept. We know what that is. So here's my y, here's my x and y. So my y-intercept is 5, which is up here, and so it's going to go, this line's going to go across like so. So here's my x, here's my y, and so that's going that way. If I said x equals 3, I would go to x equals 3 and then do this line. So this is the x equals. X-intercept. Question 8. Oh, we're almost done here. Okay, so we're looking, all these are linear. And so we're trying to figure which one has the greatest y-intercept. Well, this one I can see. Gosh, you can't see these x's and y's. This is super annoying. See, I had it wrong. So here's my y-intercept here. What is that, a -3? I can find my slope as well. So it's going up to -1. So my slope is up to -1, which equals a -2. This one, if you notice, this ordered pair here, this point, is at 0, -3. Okay? So when I'm looking here, I'm looking for that constant rate of change. And it looks like I'm increasing by 5. And then here I'm increasing by 1. So you should know slope is the change in y over the change in x, so that's a +5. My y-intercept, because you're going to compare that as well, is where when x is 0. So my y-intercept is 4. So this one was 0, -3. This is 0, 4. And again, feel free to graph any of this on Desmos. This one we already know. This is my b. This is my slope. And then on this last one, it's telling you the slope is this and my y-intercept is that. Now we can answer this question. Which function has the graph with the greatest y-intercept? So 1 here, -5, 4, and -3. So that's function 2. Which, so in case you didn't see that, in my sunshine, which function's graph is the least steep? Least steep has to do with your slope. Which slope is the smallest? This slope is 5, that's pretty high. This slope is -4, still steep as far as going negative. This one is 3, and this one is -2. So which one is least steep? And it should be the 2, the one with the 2. So that's function 1. Which functions have a graph with a slope that's less than -3? So if it's less than -3, so here's 0, here's -3, it needs to be less than -3. Less than -3. This one, is it talking about slope? Slope is 5, so that doesn't work. This is -4, so that one works. So function 4. This one, the slope is 3, right? We're talking about slope. And here slope is -2, so it is just function 4. And then the last question is talking about the vertexes. So make sure you understand the vertex is the minimum or maximum. I would definitely graph in Desmos so you can see what this one looks like. That way you can name the vertexes. This one, here's my X and Y, so that's my origin. That's 1, 2, 3, -3, and then you go up 3. So that's the first one. Vertex of the second one, I don't know. I'd have to graph it. Which one has the smallest minimum? So when they're talking about the smallest minimum, they're talking about Y values of the vertex. So once you have that, you can answer that question. All right, that's it.